The straight line L1 with equation y equals 3 over 2x minus 2 crosses the y-axis at point P. The point Q has got coordinates 5 minus 3. I need to calculate the coordinates of the midpoints of P, Q. So I know the coordinates of point Q already. Let me now work out the coordinate of P, because then I can find what's in the middle of both of them. P is where this line crosses the y-axis. So that's where x equals 0. So if I substitute 0 into this equation, I get that y is equal to minus 2. So therefore, the point P is the coordinate 0, minus 2. So I just need to find what's in the middle of these two coordinates. To do that, let's focus on the x coordinates first. So the x coordinate of Q is 5, the x coordinate of P is 0. So what's in the middle of 5 and 0? Well, it's 2.5. If you weren't sure that it was 2.5, you can do the calculation that I've just shown now on the screen, where you add the two x coordinates together and then divide by 2. 5 divided by 2 is 2.5, or 5 over 2. We'll now do the same with the y coordinates. What's in the middle of minus 3 and minus 2? Well, that's going to be minus 2.5. But again, if you're not sure about that, you can just use the trick of adding those two coordinates together and dividing by 2. Minus 3 minus 2 is minus 5. And the minus 5 divided by 2 is minus 2.5. We're then told that the straight line L2 is perpendicular to L1 and passes through the point Q, and we need to find its equation. So if it's perpendicular, it's going to have the negative reciprocal gradient. Now I can see that the gradient of line 1 was positive 3 over 2. So therefore the gradient of line 2 will be negative 2 over 3. So I can say that y equals minus 2 over 3x plus c. It passes through the point Q, which was the coordinate 5 minus 3. So the y coordinate is minus 3 when the x coordinate is 5. So let me now work out the y-intercept. Minus 2/3 times 5 is minus 10 over 3. So the c is minus 3 plus 10 over 3. The minus 3 is the same thing as minus 9 over 3 with a common denominator. And the minus 9 over 3 plus 10 over 3 is just 1 over 3. So c is 1/3. So the equation of my perpendicular line L2 is y equals minus 3 over 2x plus 1/3. We can simplify this by multiplying everything through by 3 to get 3y equals minus 2x plus 1. And I'm going to add 2x to both sides. And now this is in the form that the question asked for. We're then told that lines L1 and L2 intersect at the point R. And we need to find the exact coordinates of point R. So intersect, that's making me think simultaneous equations. So I've got my line L2 here. In yellow, this is L2 that I've just worked out. In green, we had L1 that we were given in the question. So we want to do simultaneous equations with these two. So what I'm going to do here is I'm going to take my y here and substitute it into the y here. So I'll get 2x plus 3 lots of the 3 over 2x minus 2 is equal to 1. Let's expand these brackets. Let's add 6 to both sides and collect up those x terms. The 2, that's the same thing as 4 over 2, just to make it easier for me to collect those like terms together. So I will have 13x over 2 is equal to 7, because I added the 6 to both sides, times both sides by 2, and then divide both sides by 13. So x is 14 over 13. And if I now substitute that back into either of the original equations, I think it's probably easier to substitute it into the equation for line 1. So y equals 3 over 2 times 14 over 13 minus the 2. And that gives minus 5 over 13 as the y coordinate. So the coordinates for point R are 14 over 13 minus 5 over 13.